Hi, this is a regulator circuit and I'm going to make a PCB of this circuit. So first of all, I'm going to create a schematic. So just created a new design file. Just save it to your respective location. I just saved. Now use proper page setup, page size. A is okay for me. If you want to place title block, it is okay. You can place from place title block. You want to change anything, you can edit and modify it. And this is how you can update the title block also. I'm going to update title, so it is updated now. You can see in the design file. Just save the design. Now you can place the symbols. First I'm going to search the symbol in our regular standard library. The standard library always comes with arcade software. So in regulator I'm going to search LM317. Yes, there are multiple LM317 symbols based on their packages. So I'm going to use LM317 TO package. If the symbols are not as per your requirement or pin location is something different, you can edit and modify it. Just close it after edit it. Even other symbols you can take from the standard library and edit if it is required. So connector I'm going to take connector, 2-pin connector. Yeah, the circuit is almost completed. Just recheck if anything is missed and update the package value or symbol values. This is ground symbol and even power symbol you can give. So this is input power V in and this is output power. I'm giving both the symbol different just for identification or just look wise. This is bill of material of this circuit. So in this bill of material, values, reference, manufacturer part number, manufacturer, and data sheet must be included so that it can be helpful for PCB designer to create PCB footprint. So already I have created PCB footprints. and I have provided 3D step file also. If you provide 3D step file, it is a very rare chance to get any error. So always use 3D step file in your PC footprint. So hole is not showing in the file, so just go and select plated hole. So you can see now that the dark colored part is hole in the footprint. Now it is time to assign PC footprint. So from here you can assign it. Just take footprint name and put the name into PC footprint of schematic symbol section. Property of schematic symbol. Just provide all the names. So if you want to check that if any footprint is missing, so just this is how you can check. You can create bill of material and you can check that if anything is missing in PCB footprint section of the circuit. So just run it. Okay, something was missing. So just yeah, it was bracket. Now see that all the footprints are included. So no footprint are remaining. Now it is good to go. Now it is time to run the netlist. And before that you have to provide a library path. Whatever PCB symbol, whatever PCB footprint you have given in the schematic symbol property, those location of those footprint must be mentioned in the user preferences and library section. I'm going to show that how to provide it. Just go to setup, user preferences, path, libraries. So PSM and pad, these two locations have to provide. Even step also you can provide the location of step file, but pad and PSM is very important. So I have provided both the location. In case both pad and PSM are placed in one place, it is good, and you have to provide one single location both the places. So you can see this is pad and this is PSM file. So all the files are same location. That's why I have provided single location for PSM and for pad. Now I need to create a new board file or Allegro file where I can import these footprints, these signals, the complete circuit, and I can make a PCB file. So just go to file, new board, and this is how you can create new board file. I'm going to save this new board file. Now I'm going to update unit. So updated unit and grids. If you want to change the origin, you can change. Even if you don't find the origin, sometimes it is very difficult to find the origin. So you can make your own origin. Just update it and provide the board outline. Now your board outline is done. Now it is time to generate a netlist. So I'm going to provide the location of netlist. It is created. No error came. So just import the netlist into PCB file or the board file you have just created. Just provide the netlist path. Click OK and import it. See, no error came. Here place component option, so you can see that all the components are available, but I'm not going to place any component. So sometimes it is because of you have not provided proper library path. Just because of that, all the component doesn't being placed on in onto the PCB. So what you can do, just check directly whether these footprints are being placed or not. Means into PCB you can directly place the footprints from the library. So just I'm going to check something, there is some issue. So what I'm going to do, I'm going to check, actually give the library path again. It's because of somewhere library is giving issue. So just copy the library path again, copy it and place to the library location. User preferences, path, library, and just pattern, PSM path. To both location, just provide again. Sometimes because of some text or some issue, it doesn't place. I'm going to check again. Yeah, it is being placed now. You can see that all the components are placed. Now provide the board line as per your requirement. Just select option and drag it. After drag, so according to schematic flow, you have to place. If you have two screens, it is better, since if you have two screen, one screen you can utilize for schematic and another for PCB layout. In case you have big screen, you can do one thing, you can half utilize schematic and for half you can utilize for layout. So that's how you can easily place the component and you can see both schematic and layout. For me it is quite difficult since I'm using small screen. Yeah, this is how. Just place as per circuit flow. Now sir, now the placement is done. I'm going to provide the length and width of board outline. So this is how you can provide it. Done. Now it is time to provide constraint. That means what should be length and width of trace and what should be the spacing. So go to constraint setting. Don't touch electrical. It is for high speed design. So doesn't require it now. I need just physical and spacing section. So in physical, you can see that default value is there. In case you want to add up something, you can add. If you want to update this one, it is good. Just update as per your requirement. So I'm going to update. In case you have selected the whole lines, so if you change one, all the lines will be changed. In case you have selected one, uh, this one block, then only one block will be changed.
So this is
So this is how
how
you can
after import you
give
can place
new
your
trace
components
width.
into your board outline.
Power, for power I'm going to use something thicker trace width. 0.5 mm is good for me, so I'm going to select 0.5 mm. So I have selected power net, or so this is how I have provided. Now after providing it, after updating it, now select the net where you want to add up this power net. So of course power nets are only for power signals, ground and VCC. Just select, instead of default, if you drop down you will find a neutral width. So just update it, just select power. Now I'm updating signal width, line to width and everything. But if you want to use the particular width that I have provided 0.5 mm, you have to select default. In default section you have to select the new width I have provided. So you can see that I have updated the constraint in physical section, and I'm going to use in the layout. Let's see whether the zero point 0.5 mm for ground is coming. No, it's only 0.2 mm is coming. So what I have to do, I have to choose 0.5 mm or power signal instead of default. So just go to, see here, instead of default you have to use power. So now just try to route the ground signal. See, it is 0.5 mm. It is thicker signal, thicker trace. So this is how you can utilize physical constant setting if you want to keep a particular trace width for any particular signal. See, for input also it is coming a thicker trace. You can run DRC also in middle. In case you want to use bottom line or second line, just route and double click where you want to change the layer. The new layer will come, top and bottom. This is how, just double click and you can change the layer. If you want to check something in DRC, you can check. No DRC is coming. Even if any connection by mistake missing, you can check. You can in DRC run. So I'm going to use this line into top and the small line into bottom. Yeah, it is done. Just save it. The layout is almost completed. Just provide proper trace location. In case anything is not proper, just you can update it. Select trace and slide it. You can update it. Now I'm going to provide copper plane in bottom layer. Since all the signals, all the traces which we are looking in, these are in top layer and bottom layer is empty. So I'm going to provide the copper. The ground is in bottom layer. This is spacing that you can control from setup. Constant setting in shape section. You can see that this in shape section. Copper yani shape to line, shape to wire, shape to through hole, whatever you want to change you can change. Just provide proper length, the spacing, update it, and now you can see that yes, the width is little bit increased. In case you want to update anything, instead of constant, you can directly update it into global dynamic shape section. In through all, this is a complete, this is 0. If you want to change anything, just give, the space will be increased. So now it will be zero 0.1 mm extra or 0.2 mm extra if you provide. You can see that the space is increased now. Now this is spokes or thermal, so you can select as per your requirement. The width, everything you can control from global dynamic shape parameters. Just select and update as per your requirement. We never use 2 or 3, we always use maximum 4. That is very standard for any PCB designer. So in case you are selecting the first one, so it will just give the dimension, the width, and using second one, that means it will by default it will take the width of trace. The spoke is almost equal to trace width. Just apply, you can see the difference. This is how you can control the spoke length also. So always use 0.1, mostly we use it, and other parameters also you can control from here. Just run DRC. No DRC. In the bottom side you can see that green color mark, no DRC is there. So if you want to text, just go to text, and whatever block is there, just update the block as per your requirement. And you can see that all the text in your PCB, text means reference designator, all the reference are updated. This is how you can update. If you want to add any text like positive or anode mark, you can add up like this. Just select add text and select the block right side and layers also. Yeah, this is how you can update. Even reference or designator also you can update. Just select and give the designator name. Just save it. Just provide positive and one mark for connector and positive for capacitor. If any polarized or tantalum capacitor is there. Now it is time to create netlist. So you can see that this is how you can provide the Gerber files name, and you can add as much as possible. Just add new and provide the name and provide the other files. Just select and add it. Add more files if you want. Sometimes it gives warning, but never mind. Just add it. You can see now. Now it is time to create Gerber file. Just select and check that whether everything is okay or not. Right click and select display, so all the files will be displayed, individual file will be displayed. So just select the Gerber file and right click display, so you can see that how your file looks like. Now just provide Gerber location and run the Gerber.